Hello, everybody. Welcome to the webinar. We'll start the webinar in just a couple of minutes as we wait for more attendees to join in. Thank you. Right, let's get it started. Good morning, good afternoon, and good evening, everybody, depending on where you're connecting from. Welcome to yet another Citrix Ready technical webinar in our Citrix Ready technical webinar series, where we showcase how Citrix and our partners like Acceptto today have integrated to deliver valuable products and solutions to common problems faced by our customers. I'm Anil Kumar, your host today, and I'm part of the Citrix Ready technical marketing team, managing the network ecosystem of products. And before we get started, I kind of wanted to provide a very brief introduction of what is Citrix Ready and what we do here. Citrix Ready is an end-to-end technology partner program that showcases and recommends third-party products, solutions, and services that demonstrate compatibility with Citrix. So with this, customers can quickly and easily find solutions which are trusted and recommended by Citrix. And you can find all these products in Citrix Ready Marketplace hosted at the below links. So please visit our website, and if you'd like to know more about Citrix Ready program, if you're a vendor and want to validate your products with Citrix, please visit citrix.com, partner programs /Citrix Ready, and you should have all the information over there. You could also drop us an email at citrixready@citrix.com, and we'll get back to you with all the information you require. Right, so we have Acceptto with us here today, and to present about Acceptto, we have our main speakers, Foster Oliveira and Dr. Stephen Albrecht. I'm really proud to have them on this webinar. Hi, Fausto. Dr. Stephen, could you provide a brief introduction about yourself, please?
Hello, good afternoon. My name is Fausto Oliveira. I'm the Principal Security Architect for Acceptto, and I'm sorry I'm having a bit of problem with my PowerPoint. I work with Stefan and the rest of my colleagues in multi-factor authentication supported by cognitive authentication.
And hello, my name is Stefan, and I'm the Principal Research Scientist at Acceptto. So I'm responsible for machine learning and artificial intelligence with respect to multi-factor authentication at Acceptto.
In today's presentation, I'll be talking about what are the key challenges for identity and access management, how Citrix and Acceptto work better together. My colleague, Dr. Stefan Ulbrich, will be talking about machine learning and behavioral analysis. What are the key challenges for identity and access management? Access to enterprise resources is increasingly done over heterogeneous devices, such as mobiles, tablets, laptops, fixed workstations, and wearable devices. And users expect to have access to those resources with a minimal burden. On the other side, credential compromise continues to be a key exploit, and it's becoming increasingly cheap to crack a password by brute force, as more and more hardware is becoming available. It is also estimated that 81% of the attacks use the stolen or weak password. That, combined with the fact that the perimeter no longer exists and the new boundary has moved into the cloud, is creating new challenges. The lack of auditing outside of the corporate boundary is a challenge. The security risks have increased with the abundance of containers, virtual machines, software as a service, and serverless software. But challenges don't stop there. Once a credential is compromised, it can be used to access multiple resources. Users often reuse the same password or passwords on work and personal related resources. On the other hand, password recovery continues to be a burden on help desks, consuming resources, time, with an average cost of $23 per user. This is even if you have a self-service reset facility. Increasing password complexity or rotation is not the solution. And in fact, that's part of the problem. It increases the number of password resets and encourages the reusage of credentials. Likewise, cloud and container offerings have shifted the boundaries of authentication and data protection. Constraining the user and requiring multiple logon mechanisms encourages unsafe behavior. Either pins get shared, smart cards get reused by several users. It creates a culture of unsafety. Friction in itself is a major barrier to the adoption of MFA solutions. If the user is forced to execute several actions throughout his workday, he will abandon the solution. The answer, we believe, is to use cognitive authentication combined with multi-factor authentication. And I'm about to show you how that works with Citrix. Let me show a typical Acceptto and Citrix ecosystem. On the left-hand side, we've got the extranet user and intranet user, along with the factors that are supported. On the bottom right-hand side, we've got the Radius and Active Directory servers. Those, combined with the Acceptto eGuardian API, make up the authentication and authorization solution. The NetScaler gateway is going to integrate with these components to protect what is most important for us, your corporate resources. The configuration of Acceptto and Citrix together is actually quite simple. It relies on 4 steps. Set up a non-privileged user in Active Directory. Configure Radius to authenticate to Active Directory. Add a post-authentication step to your Radius configuration. And finally, change your Citrix NetScaler Unified Gateway to use Radius for authentication. In order to configure Radius, we are going to edit the radiusd.conf file. We're going to scroll down to the policy and check that the policy is enabled. We then are going to check if sites are enabled. Once that's done, we'll proceed to edit the LDAP configuration file. And in the LDAP configuration file, we're going to check if we've got a server pointing towards our Active Directory server. And place a comment so it's easier in the future to find where that configuration directive is. We then proceed to configure the identity, i.e. which user we are going to use to connect to the Active Directory server. Bear in mind that the password is going to be in the configuration file in clear text. We then proceed to configure what are the filter attributes for the user. Save and exit. Now we're going to configure the authorized file. And in the authorized file, we are going to set up what is the behavior for the default LDAP authentication. In this case, I left a comment, LDAP users, and then As you can see, it's pointing to the DN that we've configured previously, and the default action is to accept. Then proceed to edit Perl module configuration so that it points to the script that Acceptto provides, the Acceptto Perl script. Once that's done, we proceed to edit the Perl script provided by Acceptto. And in this Perl script, we are going to insert the values of the secret and UUID that you have obtained from the Acceptto website. In order to obtain these values, you'll need to subscribe to an account with Acceptto, and within that account create an application. You can also configure a user-facing message. And one last note, please notice the URLs that are used for the authentication. You may want to open those through your web application firewall or your IPS system. Once that's done, we proceed to edit the client's conf, where we are going to configure which are the subnet ranges that will use this authentication type. In this case, I've got a range called client scalar networks that has a subnet where our netscalars are. Again, notice that the secret will travel across the network in plain text, so it's essential that this network is protected. Once that's done, we proceed to test the configuration. And as you can see, the result is that authentication was accepted. That concludes the Radius setup. Once the Radius server is configured, it's time to add it to the Netscaler configuration. In this case, I'm going to call it Demo Radius, and I'm going to use its IP address. You could also use the host name. Once more, the secret key is going to go across the network in plain text, so it's important that the communication between the Radius and the Netscaler is protected. Finally, note that I'm going to increase the timeout between the Netscaler and the Radius to ensure that we've got enough time for the REST call to come back. Now we proceed to test. And we've got connectivity between the Radius and the Netscaler. Let's proceed to the next step. Now that I've got the Radius, I'm going to associate that Radius server to a policy. And once that policy is configured, I'm going to associate that policy to a Netscaler gateway. Now that I have my policy, I'm going to create a new unified gateway. And I'm going to associate the new unified gateway with that policy. I'm going to select the authentication method as Radius, extract my policy, and just leave the values as a default for now. That's it. The configuration is done. What I'm about to show you is the experience that an extranet user would see when they're trying to log in. So in this case, I already typed in my username and password, my Active Directory credentials. When I press log on, you'll notice that there is a spinner going around there. I receive a mobile notification and I accept. By doing so, I'm authorizing this access. Now the scenario in the backend is slightly more complicated. We are not only watching for the user to log on to Active Directory and for a request to come to the Acceptto API. Within the eGuardian, we are watching what is the user behavior and assigning authentication and authorization requirements based on the user behavior. Let me stress the importance of what we have just seen. Merely having something that the user knows, such as a password, and something that the user owns, such as a token or a mobile, is not enough. This can be hacked, stolen, or cloned. Think about it. If you have a smart card and you have a 4-digit PIN, someone can shoulder surf it. If you have a mobile phone that can be unlocked using a pattern or a PIN, someone can shoulder surf it. Multi-factor approach is required, but it needs to be one that harnesses intelligence and biometrics. At the same time, user behavior analytics and biometrics are a requirement to ensure that multi-factor authentication becomes an effective deterrent when it comes to credential exploitation. All of these requires intelligence. Some multi-factor authentication solutions are cumbersome. They require the user to introduce his PIN, password, his fingerprint several times throughout the working day. And that is a distraction from their work, and it's a cause of friction for the user. On the other hand, all accesses are treated in the same way. They either pass or fail, independently of how risky the behavior and how risky the resource is. Cognitive authentication allows security without the necessary friction. We can lower the threshold at which we ask a user to authenticate based on his behavior and the security or hygiene of his workstation, or we can increase the authentication requirements if the transaction, the behavior, or his environment are deemed unsafe. In the end, less friction encourages a safer behavior and allows the user to trust and adopt the solution. The approach to intelligence needs to be one of continuous monitoring and evaluation of user behavior. That is what ascertains the unicity of a user and allows the corporations to effectively have a risk-based score around users' applications and behaviors. At the same time, the ability to have quick audits and alerts that can prevent access to sensitive resources effectively can stop breaches and heighten the security posture of an organization. Effective multi-factor authentication combined with behavioral analysis can decrease the number of different credentials required by the user and lower the total cost of ownership associated with password resets. This combination allows for less friction between security and usability. Users no longer have to know multiple passwords to access corporate resources, discourages credential reusage, and keeps the bad guys out of the door. To summarize what we've talked about so far, multi-factor authentication on its own is not enough, and can in fact be subject to some of the same issues that affect traditional passwords. User behavioral analysis adds an extra layer of authentication to the solution, and it is essential to defeat issues such as shoulder surfing, cloning of devices, and prevent brute force attacks from gaining access to enterprise credentials. As importantly, having a single pane of glass where you can watch what are the security trends inside your organization allows for a quicker response and can be used to deter hostile actors. By combining Citrix traffic security with our authentication solution, your organization gains greater protection and insights. You may recall I spoke about intelligence. In the Acceptto solution, eGuardian is where intelligence gathering takes place. And in order to do that, we analyze network forensics, we continuously monitor user behavior and traffic, and we gather intelligence from external sources. It is worthwhile to note here that for us, external sources is any application that can provide us with data about user or applications. That can be as simple as a syslog or a Windows event log, or it can be more advanced solutions such as databases. We can integrate them. Once we harness that intelligence, we have an auditable trail of user actions, applicational behavior, and transactions. We use those to compose a risk-based assessment that in turn authorizes or denies access to resources. And again, here a note. For us, any resource that can be subject to authentication is something we can protect. On the other hand, having an audit trail that is comprehensive can be used to fine-tune policies depending on how critical a resource is, and more importantly, how risky the user behavior is. eGuardian provides an auditing capability as a standalone, and in some cases it might be enough. But it really shines when it's working integrated with its ME, the client authenticator, to implement multi-factor authentication backed by user behavioral analysis.
Right. First, if I could take a quick question before we move on.
Yep.
Right. So you did mention that multi-factor authentication is not enough, and we need to monitor and evaluate user behavior, and you also did mention something about risk-based analysis.
Yes.
Could you give us a real production example which you've seen, which has really helped? And when it comes to user behavior monitoring, what exactly are we monitoring from the users?
So I can give you two examples, a positive and a negative example. I have worked with an organization where multi-factor was mandated, and they were using a smart card to authenticate to an application. And due to cost reductions, that smart card was shared amongst various employees. So effectively, it defeated multi-factor authentication. Okay.
Right.
I can give you the positive use case where, by using our authenticator, we have several financial institutions, as an example, using our backend to measure user behavior and use that user behavior to allow them to perform certain financial transactions or not. Okay. Case in point is, for example, if your PC accessing your banking website is in the UK and suddenly there is an authentication attempt coming from, let's say, China, clearly something has gone wrong and you are clearly not who you say you are. Does this answer your question?
Right. I think that's very very intuitive and very secure. I mean having to monitoring where the user is logging in and ensuring that he's at the correct place always really helps to kind of reduce those risks.
That is one of the factors we measure. Okay, we do measure other attributes. It was just an example.
Right. Sounds great, Foster.
Okay.
I think we can move on with the next slides, please.
Okay, then I'll take over. So again, thank you, Foster. So my name is Stefan Ulbrich again, and I want to give an introduction of the techniques that empowers our cognitive authentication. So the methods that give us the possibility to compute a dynamic level of assurance or risk score about a person. And these techniques are all based on machine learning. So I give a quick introduction / deep dive or overview into the materia. So I'll starting with what machine learning in general is, or which problems it tries to solve, especially in the context of cybersecurity and authentication, cognitive authentication. And in this context, there were two approaches, classical approaches. So one is that you derive policies, like the one Fausto just mentioned, that when you're in China, or transaction is triggered from China, while you are located in England, that this is a discrepancy. You can express as a rule created by humans. On the other hand, you want to use machine learning to get several benefits, or a system that can outperform what human can do there. And I'll briefly stop with introduction on the application in the scope of authentication systems. So machine learning actually and artificial intelligence are terms that are rather old, that have been in the science and the community around for quite a while. So for instance, the term machine learning has been termed by Arthur Samuels in the late 50s, and also artificial intelligence, well, a term that is more difficult to define, because, well, if we hear the word artificial intelligence, well, I first thought of Star Wars and robots running around. So machine learning itself there's a quite complex definition on there, but actually it describes a system that is able to perform a task, and it progressively improves the more data it looks at. And what's also an important point, you don't need to explicitly program anything. So the system is working actually like a black box. You bring in data, and it solves the task and gets better continuously over time. Artificial intelligence, well, basically that's only the science that deals with creating intelligent machines, whatever that might be. So it's often seen in the scope of reasoning, of solving problems, or decision making. That's actually that case where we use it here in this case. So we see it as a system that is able to make a decision on its own and doesn't need a human intervention. Whether these decisions are made from a human teacher or based on a rule set or created by machine learning is independent of this definition. Of course, artificial intelligence is the scope is much broader. It can go to motion planning in robotics or in autonomous driving, actually. So machine learning is a lot in the media recently, or basically since last decade, thanks to autonomous driving, big companies as Google. And the reason behind it, why it gained so much in popularity within the last years, or the last decade, is first that we have a lot of computational power, which we didn't have in the 50s. So our computers are much faster, and with rise of graphical processors like from NVIDIA or also Intel's dedicated processors, we have so much computational power at our fingertips and parallelized computation, which we didn't have before, but we also have a lot more data than we used to have. So with big companies collecting every data you could imagine about you, well, Facebook has been quite in the media within the last weeks, as they a little bit collect too much about you, gives us, well, the power. We have a lot of data that we cannot process anymore manually. So the time for machine learning has come within this last decade. So which problems can we solve by an artificial intelligence solution? And especially in our context with connective authentication, it is the question for us, if a user tries to attempt a resource, a web page or a server, it's a question whether we need another multi-factor authentication, so another level of friction because we don't really trust him, or whether we give him access right away to the resource. And this decision is made by a system based on knowledge it somehow has collected over the time, or that has been encoded into it, programmed by an expert, or gained from data over time. And for that, it needs additional information about the access attempt. So that's what we always call context. So context is the key about that the machine can make a decision. It has to know something about you. And again, in the example Fausto gave earlier, if you're in China, then China is one attribute. Your location is one point that is important to make a decision whether to grant access or not. And based on this knowledge base and its rules or internal happening in this black box, it computes or spits out a level of assurance or risk to score that it makes or founds a decision on. So for cognitive authentication, we need to acquire data. We need that to decide whether an access is legit or not. We have to capture the context, and we have to use as many or multiple sources as possible. So this might be a device fingerprint. For instance, your browser usually knows where you are and has a certain characteristics like which languages you've got, which plugins you've installed, whether JavaScript is enabled or not. It gives a uniqueness to you that is kind of characteristic for you, like a fingerprint in real life. But these can be faked also, of course. So we try to collect as many data as possible. We have a mobile app, so we can also access to the sensors we've got on the phone. So we can get the GPS position and can, for instance, validate whether your mobile phone is in China when the attempt comes from China. When your mobile phone is still in England, maybe something's wrong, and we access to provide another level of assurance, like a fingerprint on the mobile phone. Also, we can use other data sets from the client directly. So usually big companies collect data over the years, and they have a good knowledge about the profiles or data about the clients. And we try to incorporate that to improve our predictions, or probably even bought in third-party data sets. Okay, and the key there is we've got attributes. We collect data quite a lot. So from a browser, we could get geographic data, IP addresses, which ISP are you using, whether you're using a VPN connection or SSH over there, which browser OS. It's a lot of data you can collect over an attempt. And those can be distinguished into categorical data. That means, well, your operating system is either Windows or macOS or maybe even Linux. So these are discrete set of possibilities, but they could also be continuous. Like time is something that is continuous, of course. So you can build up a relation, and then there's an infinitive number of possibilities in between two time steps. Also, we can use data from, as I told, should collect as much as possible and be able to progress them. So from mobile devices, we can get Wi-Fi connections or whether Bluetooth devices are close to it. We can also access to biometrics or the habits of the user. When we now have this data and we want to create a policy that decides anything, it has to work on these attributes. So for instance, we've got the attribute China, but we've got the attribute the mobile phone is in England. And from that, we have to create a rule. And the best is if we combine attributes and as many as possible into very complex rules, because they will be very difficult to reproduce by an attacker can very difficult fake the personality or the profile of a person, the more attributes were taken into account. So let's take an example for a very simple rule. Basically, that's the one I just said. So we could define a rule for deciding whether we want to trigger a multi-factor authentication or not. So if we say that the position of the mobile device and the position of the web browser should be less than a mile, otherwise we'll trigger the or increase the level of friction because our reliability, our level of assurance decreased, our level of trust in the user. So I'm going a little bit more into the details and the internals of our eGuardian. So eGuardian is a policy-based artificial intelligence system. So our policies may be defined by a human expert. So that means the rule you've seen before, like that your mobile phone has to be close to your browser, something we can specify in our system manually. That means actually these rules we have got a human expert. You can read the rule either graphically or in a special language created to define those rules. You can read it, you can understand it. These rules are obvious for the human. We don't need a lot of data sets. It's common sense what we want to implement in there. So we give our system common sense for the human. And this provides a very basic and secure, highly reliable level of security. Problem is, of course, you need knowledge about what you're doing. It's called domain knowledge. You have to know the world you're operating in. You have to know how an attacker thinks, for instance. And that means it is not adaptive. You define a rule and it will never change unless you change it. Also, you could make mistakes by creating a manually. So they are rather hard to maintain and also rather expensive because you need a human to do it. Bottom line, we have very high confidence in rules created by human, but they're very narrow. You cannot possibly cover all aspects of, let's say, 100 or 200 attributes. You cannot put them in relation by hand. But what you do, you can really trust them. The alternative to that is machine learning. Machine learning this is a program or a part of our system that looks at data we previously collected. And the nature of this algorithm, we'll go a little bit into detail in 2 slides, is they detect unknown relations. They are adaptive. With the more data they come in, they detect how the things work, how an attribute like location depends on time, for instance. So in the morning, you're usually close to your bed because you just got up, just as an example. And they're working automatically. Computational power got rather cheap nowadays. So the costs are tremendously reduced using machine learning. Well, on the other side, it's less explicable. You cannot really understand what the machine learned because it's some sort of hidden in mathematical formulas. And what's even more important, you need a lot of data to be able to build your models. So you need huge data sets. So the system has to run perhaps for a couple of months before it really gets a valuable contribution. In the end, we have less confidence, but it's wider. We can introduce more security in there, but maybe we cannot really confide completely into it. So our solution, what we do in A-Guardian, is we have a mixture of experts. So that means we have multiple machines learning the human, so human-based policies, but also machine learning. And their decisions are weighted up and we make a final decision based on, well, like in the democracy, on a democratic vote, we make our decision at the end. An example with how I wanted to show that human-based policies, as good as they are, give a problem. In this image, you can see we have a user request. So we first compare the mobile browser location with the mobile phone and the browser location. If it's far away, well, check the dates. Is it possible that the last login of the phone, well, it was 2 days ago? Yeah, in 2 days you can travel a lot. So if you pass this test, whether it's plausible, or your devices were closed, you check whether the language settings have changed of the browser. If they've changed, no, I don't grant access, because who changes the language setting of your browser? If you go to China, well, I certainly wouldn't change my language to Chinese there. But if my device would have been stolen, probably a local would change it. Then we continue with checking the browser version, and so on and so on. And even if we start combining attributes, these rules get more complicated and complex. So back to the human rules. They are human readable. You could see it on the right side. You can create them with a graphical editor. You don't need programming for that. You can just create a graph like you've seen on the right side. Or you could write it in a domain-specific language, or if performance is the most thing you care about, you could write directly in a programming language. You could even do it directly in SQL and create a database looking for examples where you accepted a request in the past, for instance. But the more attributes we get, the more complex this graph gets, and the combination. So if you say you have 3 attributes, and each attribute can have 3 values, then the combinations, it's 27 combinations. So it grows exponentially very, very fast. And this holds especially if you have numeric values. Time, the number of logins per month, for instance. So in the example of the right, where do you do the threshold of being too far away? These are things that are quite complicated for humans to do. However, combined attributes are the key to the increased security. That's why we go to machine learning. So here you see on the right, it's a mock-up where you can see how the result of a machine learning looks like, what the machine thinks. And basically they are thinking in mathematical equations. So you can see here we have a set of fraudulent attempts, which are pointed red, and a set of good attempts pointed in blue. And you have got 3 attributes. And this blue curve separates them in this mathematical world. Let this be an example for a perfect classifier, whether something is bad or going on or something is really fine. No human can really deduce a policy in a written form from that one. So the knowledge is implicitly stored in these things. Good things, to make it fast, typically we don't need any domain knowledge. We can work very well with a lot of number of dimensions. So all the aspects we can get from a browser fingerprint, we can use. We can use all the data you collect from your phone, no problem. So the higher the dimensionality, of course, this imposes problems as well, but it will outperform any human. And we can also define nonlinear relationships. So they're really complex things in there. Again, bad thing, in order to get those models, we need a lot of data. But we can mostly adapt over the time. So if the attackers get new trends or new ways of attacking your system, the system will slowly, but it will adapt to it. So we'll keep up with them in the best case. A word on the methods we use there. They usually come from a field in mathematics called anomaly detection. So you can use it in medical data or in network analysis or in authentication, like in our case. And they also classified as unsupervised learning. That means when you get a request in your data set, nobody told whether there was an attacker or not. You cannot really know that. So you don't have this data, but the algorithm is still capable of detecting in your old data, which nobody had the time to look what was good or bad. This algorithm can find it. Typical examples are support vector machines, neural networks, or clustering algorithms in general. So machine learning can combine many different sources. So I talked a lot about device and browser fingerprints, but also you can do biometrics from fingerprints to face recognition easily, also to movement. You can even connect those algorithms to observation cameras. So machine learning is a huge field and covers so many aspects of our lives. You also can, and that's one core aspect that we have in eGuardian, you can create predictive models. So on data that is highly temporal, like the routine of your daily commute route or getting up at your home, then you go to work, then you go to the gym. So regularities that you have every day. If you differ from those, the machine will detect it, that your daily routine is perturbed, and it will ask you, hey, is it still you? Because you behaved rather abnormal today. Please give your fingerprint just to be sure. And when we combine these additional dimensions or attributes, or how you want to call them, so if we fuse multiple data sources into the system, we, on the one hand, increase robustness. So we can rely on what we're doing. And also the precision will be very good in the end. And for an attacker, well, that's basically the assumption we have. It is impossible to imitate all aspects of a person, of its behavior. It's something that makes us unique. If an attacker would be able to really imitate me completely fine, he would also be able to trick any human being. So we assume that up to a certain level it's possible, but the more data sources we combine, it will get hard to impossible to break this level of security. So in the end, it leads to a reliable and dynamic level of assurance. So we were talking a lot about machine learning. So in our opinion, it outperforms the human in many aspects. It can handle unknown data. It can find its own domain knowledge. We don't need an expert. It can handle data sources from everywhere and no matter how many facets this data may have. And it's flexible. It will find out novel trends and attacking your system. And it's much cheaper and easier to maintain. And it's what powers our eGuardian on the bottom. On the other hand, human policies still are the most reliable source of what you can define. They're hard to maintain, but in combination with a machine learning as a mixture of expert, it becomes a really unbeatable system. Thank you very much.
Thanks very much, Dr. Stephen and Foster. I think it was a great presentation, although we had a bit of audio issues at the end. I think we can sort it out when we upload it on YouTube. But overall, a fantastic presentation. We have a few minutes for the questions. Let's take up a few. So the very first question which comes to my mind, I think we have a few IT specialists from various enterprises who are attending today. So if they would like to know how to implement Acceptto's eGuardian and the It's Me solution in their environment, how easy is it? Is it a cloud-based solution? Do they have to install anything on their internal servers? Like if they have to set up a POC, how easy is that?
If you don't mind, I'll fill that question. So the simplest way to set up a POC right now is to go to our website, www.acceptto.com, and subscribe yourself to our free service. Download our mobile app and follow the instructions on the website. It really takes, I would say, 5 minutes to get you set up on our website. And once you have done that, as I showed on the demo, setting up radios, even if you don't have an Active Directory, let's say it's a couple of hours of work, and you've got a demoable solution that you can go out and meet with your customers.
Great. That sounds great, Foster. Thank you. So the second question I had is, so for the user behavior analysis and the risk-based authentication to work, I think we are collecting a lot of information from the end users, machines, and their behaviors. So where is this data stored and how secure is this?
So I think I answer this question. So if it comes to the mobile solution or behavior of your phone, that's a point that's very critical to many users because it captures so many aspects of your life. And depending on the needs, so this can be opted in and opted out on, well, it's in development right now, to be honest, on It's Me. You can choose whether you have this computation having on your phone. Of course, if you transmit the data to a server, you can capture more in that finer intervals because you have more computation power in the cloud than you have on your mobile phone. But on the other hand, you can opt in to have it locally on your phone only. It will also save a lot of bandwidth, but affect a little bit more your battery time. But we can guarantee that no information about you will leave your device if required to do so.
All right, that's very helpful to know.
If I may add, Stefan, we anonymize the information, so it's.
Oh yes, of course.
Yeah,
sorry.
Sounds great. So the next question. So how does Acceptto's Acceptto leverage the context and user behavior analytics to balance risk and friction for our enterprise clients and their users.
Okay. Well, I spoke about friction earlier on, and how some solutions force the user to either type a PIN or swipe their finger or show their face several times an hour, and that creates hostility from the users towards the solutions. In our case, what we do is, once we establish context and we are tracking the user behavior, we can lower the barrier. For example, you authenticated successfully at 10 o'clock in the morning, you are in a safe environment, all the measurements show us that you are a very secure person. We won't ask you for your password until, let's say, lunchtime, because we are watching your behavior, we are not doing anything out of the ordinary, none of the characteristics that mark you as you, your identity, have changed. So why ask you to provide another password or to swipe a finger or present your face? And that's where, as I said, continuous cognitive authentication is essential. And that's what we use to introduce our user behavior analytics. It's not a mere, a table of distances. It's a set of attributes, as Stefan mentioned, that we use, and we keep track of them continuously to monitor the user and to make sure that his access is safe.
Right. Sounds great, Foster. And do you have any examples of having your solution implemented in let's say the healthcare vertical, where we do not want the doctors to kind of spend a lot of time entering the username and passwords, and they are on the move all the time. So how does Acceptto help in these cases?
We do have solutions where we use other values, such as, for example, wireless and Bluetooth, to monitor presence, and use that as part of the authentication equation. And we can always give more weight to an attribute versus the other, but it will always require, as I said, a multitude of attributes or factors in order to authenticate. But to answer your question, in the end, yes, we do have use cases in the healthcare.
Right. All right. That sounds great and very helpful. And Dr. Stefan, we talked a lot about artificial intelligence and machine learning, and although it was it came into picture a really long time ago, it's now becoming one of the well-spoken or mostly researched subjects on. So what are the applications of AI, ML, and cybersecurity, and how does Acceptto use AI, ML to reduce the friction of transactions while elevating the trust?
Okay, it is the core of the whole system of the cognitive authentication. Well, basically, the word cognitive refers to the artificial intelligence in there. So we collect the data from various sources, and the machine, policies derived from machine learning in this whole artificial intelligence system, combined with rules that could be programmed by a human expert, will make the decision in cybersecurity whether to grant access to a certain resource or not, or increase the barrier, or in the end, ultimately, even perhaps lock you out of the system if there's strong evidence that this is an fraudulent or a malicious attempt.
Great. So we have time for one last question, and any quick thoughts from both of you. So I think you did mention, but if you could reiterate how machine learning is more advantageous than the manual policy-based or role-based authentication.
I didn't get completely the question. So your question was what are the advantages over machine learning versus the human manual made policies. Okay, I had this on the slide. So the basic thing is, the most important thing is that differences when a human creates a role, we do it with our common sense. So if you look at the example of, we're assuming that you're in England, but there's a login attempt with your username from China. It's a common sense that this is physically not possible unless you're Elon Musk and build a Hyperloop until there. And you got there in 30 minutes. So that's common sense. So you understand what a human defines and you trust what a human defines. So that's the biggest advantage a human has. But the human, when he defines a role, these will be simple roles. It will be England at noon, China at 4 o'clock after in the evening. That cannot be. It will only have 2 factors in there, or perhaps a little more, but not too many. And in the end, you can fake those all. You can easily in a browser fingerprint fake that you're from the country where you are. You can at least attempt it, but you cannot cover all possible aspects. So we have much more factors that we can derive, that we can cover about you, but that you cannot cover anymore by a human, because it's getting too complex. So the possibility, the space of possibilities grows with the combinatorics. So it's exponentially growing, so fast growing that we cannot comprehend it as humans. But for the machine, that does make a problem. So they can define rules, which are working very well, but with the complexity also comes that we cannot really understand what the machine is doing. It's becoming a black box for us. So we know how the algorithm works, but we cannot interpret what's stored in there. So the mixture of both, combining the human together with the machine, gives us the ultimate trust in the system.
Sounds really great, Dr. Stephen. Thank you very much for that.
Thank you.
Right. I see a few attendees asking if the webinar is being recorded. To answer that, yes, we are recording the webinar and will share it with all the attendees within a day or two to your registered email addresses. And with that said, I want to take a moment and thank Fausto and Dr. Stephen for making this fantastic presentation and sharing great insights with us. And last but not the least, I want to thank each and every one of you who were able to attend today's webinar in the Citrix Technical Webinar Series. And this shall conclude our broadcast for today. Thank you so much, everyone.